Okay, so we have spent the last couple of lessons working on the stuff that's not in the blue box. Today we're gonna go there. We're gonna figure out what happens if one event affects another event. Okay, so I just wanted to remind you of the problem that we talked about yesterday, where we had 6 red marbles, 7 blue marbles, and 7 green marbles, and we were looking at the probability that you take one marble out and then another marble out, and they're both red, but you don't put that first marble back into the bag. So we would do P of A, or the first event is red. Then we multiplied by P of red, probability of red again, without replacement. Okay, and so what that means is we have to change the denominator and the numerator of P of red. So we found that P of red, the first one, was 6 out of 20, and we found that this one was 5 out of 19 because there were 19 marbles left and 5 of them were red, and then we multiplied these. Remember, we got 7.89% of the time. This is a contingent event or a dependent event. Those two words basically mean the same thing, but what they mean is one event affects the other one. And this thing right here is the probability with a change in the probability from trial to trial. Another way we can represent these contingent events is by using what's called a contingency table, and that's what this is. And so if we look at these people, these are people who are millennials who were born in this time range, years range. These are the sort of party breakdowns of these people. So we have our Democrats, this is the number of people in that category. We have independent voters, and then we have Republican voters, and then we have people who did not respond to the survey. Okay, these numbers are in millions, by the way, and so just be careful of your units. This contingency table thing allows us to analyze the relationships between two different sample or two different survey questions. So one question is, what political party do you fall in? And the other is, what generation were you born in? And so we can kind of look at what are called crosstabs and look at how does this survey interact? How do the data interact with each other by looking at these tables? Okay, so what we're going to do is we're going to find these totals of each row. So we're going to add this row and give it our total here. We're also going to add the columns down this way to get these totals down here. I'm going to do that without making you watch me do that. So then I'll just jump back into the video when I'm done with that. Okay, so these are the totals that I have done so far. So this total is these numbers added together. This total is these numbers added together, etc. And then if you look at the crosstabs this way, the total of these numbers is this number, etc. The one thing that you need to be a little bit careful of is just this very last box down here. This is the total, which is either the sum of this number or the sum of this number. It should be the same. If it's not the same, that means you made an error, but take the easier numbers. So we're going to add these numbers together. They should match, and we're just counting all of the people total there then. And so there we get 217. Remember, this is in millions, so we're measuring 217 million people. Okay. Before we start using that contingency table, we need to just talk about one piece of notation. This notation right here, remember that P of something is probability. And so this right here says, what's the probability of B? Probability of B given that event A has happened. Okay, so what this means is we are already assuming that we know that this second piece of information has happened, and now we're measuring the probability of this event happening there. So you need to be careful about that notation. The prerequisite item is the A. So the A is the thing that happens first, and then the B is the second thing, almost. Okay, so hopefully that clears that out a little bit. Okay, so here's that finished chart again from the first table that we saw. And let's look at a couple of different types of probabilities. And so here's sort of the setup here. We are randomly, whoops, we are randomly choosing one person out of this group. Okay, now if we're measuring what is the probability that you randomly choose somebody and they are a millennial, well, the total number of millennials is 62 million. So 62 million out of the total. The total is 217. So 62 out of 217. We'll go back and fill in the percentages in a second here. Similarly, we can look at just the people who are independents, and that's this whole column. All of these people are independent, and that means that the probability that you randomly choose somebody and they are an independent voter, that means that it's 79.47 out of 217. So the same total still. Okay, this is where the contingency table gets helpful. The next one says, given that we are looking at people only in the greatest generation, what is the probability we randomly choose one of those people and they are Republican? Okay, so now what we're doing is we are looking only at the column, or excuse me, row called the greatest generation. Okay, out of these 28 million people, so that's going to be my denominator now. So out of my 28 million people, how many of them are Republican? Well, that's this number right here, which is 10.64. Okay. Similarly, we can do the same thing with the Democrat, or with the probability of somebody who's a boomer, given that they are a Democrat. So we're going to start by looking at only the people who are Democrats. And so that is this 73.11 million people. And then given that we're looking only at that Democrat column, what is the probability that they are a baby boomer? And so that would be this 24.5. So we're going to do 24.5 out of our total, which is 73.11. Okay, so what's critical here is that the denominators here are changing. And so the denominator is no longer 217 when we have these contingency tables. What we're really looking at is we're looking at a small subset of this data to figure out probabilities within those. Just for your reference really quickly, I put in our percentages equivalents here. And so, yeah, what I would say about this is that you have to be careful about your interpretation of these two percentages because they're contingent probabilities, because they have a limiter on there. That means that this is not 38% of the population. This is 38% of the people who are in the greatest generation. This is not 33.5% of the total. This is 33.5% of the people who are in the greatest generation, etc. So just be careful about that interpretation. Okay, now let's look at some ands and ors. So if we look at the people who are both millennials and Republicans, so that is just this region right here. If you randomly choose someone out of this entire sample or this entire group of people, what's the probability you randomly choose somebody and they are a Republican and are also a millennial? Okay, well, this is 10.54 out of 217. You can figure out what the percentage is here. I'm not going to spend a lot of time doing that today. Okay. Yesterday when I talked about OR, I made a small mistake. And so this unit we're talking about and or and not and or. And so I want to show you some stuff about inclusive or today. And so I'll try to be really clear about when I'm looking for or but not both, or if I'm saying or and also. Okay, so this is, I'm gonna say, let's say and or here, because I want to explore that possibility too, because I think this is kind of interesting too, and sometimes we want to know this information also. So who is in the boomers? Well, it's these people. Who's a Democrat? Well, that's these people. Who are the people that we counted 2 times? It's the people who are in this 24.5%, or people, million people. So what I'm saying here is in this 70 million people, we have counted this 24.5. But also in this 73.11, we have also counted this 24.5. So while we want to count everyone in both of these categories, we don't want to count this group right here 2 times. So what we need to do is we need to count the boomers plus the Democrats. But this, remember, it's double counting this area right here. So we need to subtract off the people who are in both categories. So this allows us to remove the double counting, and it accounts for everybody still. Okay, so who do we have? Well, we have 73.11 million Democrats plus our 70 million boomers minus our 24.5 million people who are in both categories. So we're not getting rid of those people. We're just making sure we only count them 1 time. Okay, total. This adds to 118.61 out of the total. The total is 217. Okay, so there it is. As a percent, that is 54.66% or so. Those people are either boomers, Democrats, or both. This is last year's slide, so we should make sure we have an and here. Okay, so if we have just an and, not an or, but just an and, we are looking at the probability of A, which is just the first event, times the probability of the second event, given that the first event has happened. Second, I misspelled this, second event given the first. So we know that A has happened now. So what's the probability that B happens in that case? If we're looking at an and or, then take the probability of the first event, add it to the second probability, subtract off what's called the intersection, which is just the both. That just allows us to, because these people are already in this group and this group. So if we get rid of this group 1 time, we're just getting rid of the double counting. There is sort of one more way to represent this contingent events or dependent events as a probability. And so I want to bring up this other way, which is with a tree diagram. So I'm gonna introduce this poll, and we'll probably use this poll a little bit more next week, or I guess at the end of this week, when we get to our statistics unit. But I want to kind of talk about a little bit of probability stuff here too. So what this is there's this big university that I guess I don't know how big the university is, but this is a big polling firm. And what that does is they call people and they ask people questions, and then they gather all the results. And so here are some results that we got from an early February poll. I chose this poll because there's some current events going on in it. The sort of other font here is just a screenshot from their website, and it's about people's opinions of the 1.9 trillion stimulus relief bill that's happening in the Senate and House of Representatives right now. So this is a current event, and I wanted to talk about sort of what types of people are supportive of the plan and who is critical of the plan, and how might we examine those relationships a little bit. So let's take a look at this. The top line, which is what we say like the main idea here, is that 70% or so, well, 68% support this plan and 24% oppose. Now that doesn't add to 100, which means that there are some people who don't really have an opinion of it. But what's important here is we also have a breakdown by political party. And this is kind of interesting because it shows different pieces of information. So we have some information about Democrats. It says Democrats support the plan 97% to 3%. It says independents support the plan 68% to 25%. And then it says Republicans are opposed 47 to 37%. Okay, so this is a little bit confusing the way that they have written this. It says opposed, which means that 47% of Republicans opposed and 37% approve or support. So what I'm getting at here is it depends on what political party you are to say what your opinion of this plan is. And this sort of makes sense, right? Because President Biden is a Democrat. And so it would make sense that a lot of Democrats are supportive of his plan. And it makes sense that Republicans might not be as supportive of that plan. I also realize that I need one more piece of information to build this tree diagram, and that is that we have, I'm going to change this word voter to participant in the poll. Okay, and I want to tell you what the breakdown of people's party identification is here too. So we have 23% of the respondents of the survey said Republican. Democrat was 31%. Independent was 35%. And then other or don't know was 11%. Okay, so this breakdown is not saying this is how many people there are in the country who fall in these categories. This is just the set of people that they interviewed for this poll. Okay, so if I make a little tree diagram here, I'm going to start by saying, okay, well, let's start breaking it down by political party. So we're going to copy our 23% Republican, put that here. We're going to copy our 31% Democrat and put that here. We're going to copy our 35% independent and put that here. And then we're going to take our other or don't know and put them here. So this is getting a little messy, but that's okay. Okay, now let's look at the opinions of these different groups given that they are already separated out into their political party. Okay, so let's look at Democrats. Democrats said, okay, well, there were two options for Democrats. They said support or don't. So this was 93%. Nope, just kidding, it was 97. And this was 3%. Okay? If you were an independent voter, they said, okay, well, there are actually three options here because if you look, these don't add to 100. So this was 68, so this was support. This was don't, and that was 25. And then there's like a chunk of people who didn't know or didn't respond or didn't offer an opinion. And so if you check, 68 and 25 is 93, and so that means that 7% of the people, we're going to say, abstained because they chose not to answer the question. We do not have any data about the people who are in other categories, so we're just going to ignore this part because we don't know. This information isn't given to us. We have information about Republicans. They had support, oppose, and abstain also. So we had 37 support, 47% don't, and 16% abstained. So my question here up here is, what's the probability you randomly choose a participant in the poll and they are an independent voter who supports the 1.9 trillion stimulus package? Okay, so we're going with independent voters, so that's down this way, and then we're looking at the supporting the stimulus package. Okay, so to get P of independent and support, we need to do P of independent times P of, okay, support, given that we're looking at independent voters. Okay, so what we're really doing is we're taking this 35% and we're multiplying it by this 68%. So 35% is right here. This is 68%. Just as a little quick thing about multiplying percentages, make sure you use them as decimals. 0.35 times 0.68. And our answer here is 23.8%. What that means is if you randomly choose one of the people who did this survey, 23.8% of the time you get someone who is an independent voter who supported the $1.9 trillion package. That's a whole lot to say, hey, you can use a tree diagram, and when you use a tree diagram and you're looking at the stuff that you're trying to find, you just multiply the probabilities. So we multiplied this 35 and this 68 to get our answer, but that's what this formula is saying to do. Here's the summary slide, and this is just helpful for us. This is the probability that we could have both here. That's a possibility. So this is and or, and down here, I'm just going to put the ones that are exclusive or. So here they are. Really what it is we're taking out what's called the intersection twice. So the part that represents the people who are in both categories, we just remove them twice because we don't want to count them either time. So that's the difference between this formula and this formula. Depending on the context of the problem, like if it's a contingency table that I give you, make sure to just sort of use the contingency table and don't worry too much about these formulas. But if I tell you like what are the probabilities of two different events and I tell you what the situation is, you might need the formula. Most of them you can kind of puzzle out just by looking at the context of the problem and figuring out what's supposed to happen. But if you really struggle with that, a tree diagram can come in really handy often. You're going to have a little bit of practice just to get kind of used to some of this stuff, and then you'll have a little assessment on the probability section of this unit. After that, you're done for the day.